Right, hello, welcome to yet another C2, so it's January 2008 this time. Okay, right, so to start, there's our usual kind of bog standard differentiation and integration. So here they want us to differentiate. So we've just got to remember to times by the old power and take away 1. So 10 times 4 is 40, x cubed, and then the 12 disappears. So we just want 40x cubed for that. Okay. Question 2, so a sequence begins, so it goes 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, blah, blah, blah. So we're assuming it carries on in this pattern, like they say. Find the 48th term of this sequence. Right, so this isn't anything to do with arithmetic or geometric sequences, because this isn't an arithmetic or geometric sequence. But we can see it is periodic. It repeats this pattern every time. So we can see that every 5 terms, it would have hit 5. So we can think if we're talking about the 48th term, well, 48 divided by 5 is going to be 9 with a remainder of 3. So we know it's going to repeat this process of having 1, 2, 3, 4, 5, 9 times, and then there'll be 3 more terms. So the 48th term will be a 3, will be the answer to that. And again, the sum of the first 48 terms, so we can see 9 times it's got to do this 1, 2, 3, 4, 5 pattern. So 1 plus 2 plus 3 plus 4 plus 5 is 15. So it's going to do that 9 times. And then we're also going to have this 1, 2, 3. So I'm going to do 9 times 15 plus 1 plus 2 plus 3 gives me 141. Okay. Question 3, we're given that tan theta is a half and the angle theta is acute. Show that without using a calculator the cos squared theta is 4/5. Okay. So I think there's a couple of ways of doing this. One of them is drawing out a triangle, another one is using an identity. So let's do it using a triangle to start. So if tan theta is a half, that means this is the opposite is 1 and the adjacent will be 2. So here we have 1, 2, and then if we want to find the hypotenuse, we can do 1 squared plus 2 squared and square root it. So this would be root 5. So then if we work out cos of that angle, we can say cos theta is adjacent, which is 2, over hypotenuse, which is root 5. So cos squared theta equals that squared, so 4 over 5. I think that the way they want us to do it is using an identity. So tan theta equals a half. So tan theta is the same as saying sine theta over cos theta. So if I kind of cross multiply, we can see 2 sine theta equals cos theta. Okay, so how do we show this? Well, we know that sine squared theta plus cos squared theta equals 1. So if we sub in something to get rid of sine, then we can make cos squared theta the subject and get something like this. So to make sine the subject, I'm going to divide this by 2. So I can say that sine theta is cos theta over 2. Now, this isn't sine theta, this is sine squared theta, so we're going to have to square that. So we'll get cos squared theta over 4, because we've got to square the denominator as well, plus cos squared theta equals 1. And now we just need to think, well, how many cos squared thetas have we got? So we've got 1 plus a quarter, in other words, 5 quarters cos squared theta. And then if we divide by 5 quarters, we get 4/5 on the right. Okay, just to make that clear. So 1 over 1 over 5 quarters. We times top and bottom by 4, we get 4/5. Okay, let's catch up with the mark scheme now. So 1 mark 40x cubed, you lose a mark if you left the constant. Mark for 3, 2 marks 141. So the way they want us to do it, they did want the right angle triangle way actually, with sides 1 and 2, Pythagoras to get root 5, and then cos theta to do that. And you can get the marks for doing it this way as well. Alright, question 4. So figure 4 shows a sketch of the graph y equals f of x. On separate diagrams, sketch graphs of the following, showing clearly the coordinates of the points corresponding to a, b and c. So y equals 2f of x. So this should be a kind of stretch vertically, scale factor 2, away from the x-axis. So make sure you revise your transformations if you're not sure about that. So if you like, all the y coordinates are going to be doubled, and this is going to be stretched further away. So instead of crossing at 3, it's going to cross at 6. 1, 3 is now going to be at 1, 6. 2, 1 is now going to be at 2, 3. Notice all the x coordinates are staying the same. C will be at 3, 6, because the only thing that's being stretched are the y's. So that would look like that. F of x plus 3, now this is going to move it to the left by 3. So this is a translation. Again, if you're not sure about that, you need to revise transformations. So this will affect the x coordinates and not the y coordinates. So this is all going to be shifted 3 to the left. So that point 1 minus 3 is now going to be 3 to the left, so it's going to be at minus 2, 3. So it's going to come in, go there. 2, 1 is going to be at minus 1, 1. So I've taken 3 off 2. Minus 1, 1. That 3, 3 is going to be on the y-axis. So that's going to be 0, 3. And then carrying on. Alright, let's have a look at the mark scheme for that and see what they wanted. So, as long as all your coordinates there are correct, you're okay. Okay, right, I'm getting lost now. So question 5, we've got another, well, we've got an integration now. So it's indefinite, so we don't have to plug in any numbers. Okay, so first of all, we need to, remember, add 1 to the power and divide by the new power. So it's going to become x to the 6 over 6. Now, cube root of x we need to remember is the same as x to the power of a third. So we're going to add 1 to that and divide by whatever we've got as our new power. So a third add 1 is 4/3. And then we've got to divide by 4/3. And the 7 is going to become 7x. And don't forget the plus c, because you'll lose a mark if you forget. So that's going to be 2x to the 6. This 3 kind of jumps up to the top, or you can think of timesing top and bottom by 3. So we get 3x to the 4/3 over 4 plus 7x plus c. Right, question 6. Sketch the graph of y equals sine theta between 0 and 2 pi. So we're working in radians. So to start with, remember 2 pi is the equivalent of 360 degrees, and you'd all know sine theta looks like this. So here's 2 pi, here's pi, pi over 2, and 3 pi over 2, and then just show it goes between 1 and minus 1 for that sketch. Right, so now we want to solve the equation 2 sine theta equals minus 1 between 0 and 2 pi, giving your answers in the form k pi. So we need to write it in terms of pi. So that would mean sine theta equals minus a half. Now if you put theta equals sine to the minus 1 of minus a half in your calculator, and make sure it's in radians because this whole question's in radians, you should get minus pi over 6, which is the equivalent of minus 30 degrees. So that's a bit troublesome because it's not in our range, it's somewhere over here. So here's minus pi over 6, and we're down at here. So we need to look across at our curve and think, well, where is the curve at minus pi over 6? So to do this, you need to use a symmetry. So we can see it's symmetric around pi over 2 or 90 degrees. So we can think if we've had to go pi over 6 radians away from 0, we're going to have to go pi over 6 radians away from pi. So this value here is going to be pi plus pi over 6. So if you've got a pi and another sixth of a pi, you've got 7/6 of pi. So that's one result, and it's in this form that they want. And then this result over here is going to be 2 pi minus pi over 6 because we've had to go pi over 6 back from 2 pi. You could even think of it as adding on 2 pi to the whole to this result here. So if you've got 2 pi's and you take away a sixth of a pi, you've got 11 pi over 6 or 11/6 pi, and that's your 3 marks. Right, let's catch up with the mark scheme. So there we can see solutions for that. So 5 marks for doing all of that, 1 for the first term, 2 for the second term, 1 for 7x and 1 for plus c. So this part, a correct sine shape through 0, amplitude of 1, period 2 pi, and then 3 marks for that. Okay. Question 7 is a bit all over the place. So first of all, we've got this sigma notation question. So this means the sum from when k is 2 up to when k is 5 of 2 to the power k. So that means we need to do 2 squared plus 2 cubed, etc. So what this means is sub in each number from 2 up to 5 into whatever expression is in front of it. Okay, so that's going to be like 4 plus 8 plus 16 plus 32. Obviously you can put that all in your calculator and that gives us 60. Right, find the value of n for which 2 to the power of n is 1 over 64. So we need to convert this into a power of 2. I guess you could do this using logarithms, but it's overkill really. You should hopefully recognise 64 is a power of 2, so 2, 4, 8, 16, 32. So that is 2 to the power of 6, and because it's 1 over, that's going to be the same as 2 to the power of minus 6. So n would be minus 6. Right, sketch curve of equation y equals 2 to the x. So I'm afraid this is something you just need to know really. So any exponential curve with a positive value of a is going to have this same general shape. So it has an asymptote on the x-axis. It's never going to touch the x-axis. They always go through 1, the reason being anything to the power of 0 is 1, and then they shoot off to infinity. So apart from this intersection here, there aren't any intersections at all. So if that said 3 to the x, 5 to the x, 9 to the x, it would always have this same general shape. Okay. Right, question 2. So we're on to another sequencey, progression-y type question, but for this one they're telling us it is a geometric sequence. So to start, second term, blah, 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 of a geometric sequence is 18. So I like to write down everything they're telling me as I go. So the second term is 18. The fourth term is 2. The common ratio is positive. Find the sum to infinity. So to find the sum to infinity, we need to know the first term and the, what do we call it, common ratio. So if you remember, U2 is the same as AR. So remember, generally the nth term is AR to the n minus 1. So this is going to be AR to the 1. U4 is going to be AR cubed. So these are kind of like simultaneous equations. We can just, if we do this equation divided by this equation, that will eliminate A because both of them are times by A. So the left hand side would look like AR cubed over AR. The right hand side would be 18 over 2. So A's cancel. R cubed divided by R is R squared, and that gives us 9. Whoops, I've done that the wrong way around. Sorry, that should be 2 over 18. So that would be a ninth, which means R will be the square root of a ninth, which is a third. Now usually I put plus or minus, but they've told us it's positive, so we know R is a third, and then we can sub back into either one of the other expressions to find U1. So as AR is 18, that means if we sub in a third, A over 3 is 18, so A will equal 18 times 3, which is 54. So now we can do our sum to infinity, which is A over 1 minus R, so that's going to be 54 over 1 minus a ninth. Which is 243 over 4, or if you prefer decimals, 60.75. Okay, I'm just going to make sure I've made no mistakes there. So there's our 60, our minus 6, and the curve. And I have done something wrong. So we did get the 54. I've just put in a 9th when I should have put a 3rd there. So that was a stupid mistake, really. So here, this should have been a 3rd, which would have given us, I assume, 80. Let me just double check. 81 even. Alright. Okay, question 9. So 4-mark log question. We're given that log y is 3x plus 2. Find the value of x when y is 500. So when y is 500, that's going to be log 500 equals 3x plus 2. And now we've got to make x the subject, really. So we can do log 500 minus 2 divided by 3. That looks suspiciously easy to me. I guess it's only 1 mark though. So log 500 minus 2 over 3 to 2 decimal places is 0.23. It's all in my calculator. Part 2, find the value of y when x is minus 1. So now we get log y equals minus 3 plus 2. So minus 3 plus 2 is minus 1. So then we've got to think, how do we unlog something? So the opposite of logging is doing it to the power of 10. So if we do log y to the power of 10, sorry, wrong way around, 10 to the power of log y, that cancels out the log. And then we've got to do 10 to the power of minus 1, which is a tenth, or 0.1. Alright, express log y to the 4 in terms of x. Right, so I would... right. So log y to the 4 is the same as 4 log y. Now we know that log y is 3x plus 2, so this is going to be the same as 4 lots of 3x plus 2. So we've just had to apply that log rule there, so we get 12x plus 8. Right, find an expression for y in terms of x. Since here we've got log y in terms of x, but they want just y in terms of x. So as I said before, all we really need to do to undo this log, just like we did in part 2, is do 10 to the power of it. So this is going to be 10 to the power of 3x plus 2. Okay, let's just double check that because that was a bit of a weird question. Right, so yeah, there we go. So 10 to the power minus 1 not sufficient there, so you do need to make sure you put 0.1 or a tenth. That's the only thing I'd say from that. Alright, so question 10. So on section B, figure 10 shows a solid cuboid with a square base x, height h, its volume is 120 centimeters cubed. Find h in terms of x. Hence show the surface area of the cuboid is given by this. Alright, so you can feel this gearing up to be an optimization question when they start getting you to find formulae for things just in terms of one variable. So let's think what we know. We know its volume is 120 centimeters cubed, and the volume is going to be x times h. So we know x squared h equals 120, and we also want to find a formula for the surface area, and then I assume that's going to rely on h, and we've got to get rid of that somehow. So the surface area, we've got the top and bottom, which are both x squared, so we've got 2x squareds, and then all these bits around the side are each going to have area xh, and there's 4 of them, so there's 2 we can't see. So that's going to be plus 4xh. Right, the problem is though, this just has x's in it, we need to get rid of this h. But we also know this link between x and h is that h is 120 over x squared, so I can replace the h there with 120 over x squared. So we can see one of these x's will cancel, and we're left with 4 times 120 over x, which nicely is exactly what they've got there. Okay, good. Part 2, find dA by dx and the second derivative. So we need to differentiate this twice now. So dA by dx will be, so the 2x squared will become 4x, and then 480 over x, we've got to make sure we write as 480x to the minus 1, and then remember the power drops to the front and we take 1 away, so we get minus 480 x to the minus 2, and then repeat it for the second derivative. So 4x becomes 4, and then we've got to do minus 480 times minus 2, so we get plus 960 x to the minus 3. Right, hence find the value of x, which gives the minimum surface area. Find also the value of the surface area in this case. So we're going to have to work out when this is a minimum, and then we're going to have to sub in to work out what the actual surface area is. So if it's a minimum, that means we need to set the first derivative to 0, and that will give us the values of x where we have a stationary point. Okay, so that would mean 4x equals 480 x to the minus 2. Or let's write it as 480 over x squared, now we're trying to solve it. So 4x cubed will equal 480, which means that x cubed will equal 120. So x will be the cube root of 120, 4.93. But I'm going to keep that exact answer in my calculator. So that's the 3 significant figures at the moment. Right, now let's sub it into, now we're not actually told to prove that it is a minimum. To do that, let's sub it into the second derivative just to make sure it is. So I'm going to do 4 plus 960 answer to the power of minus 3, and I get 12. So because that's a positive number, it means this will be a minimum. It might be worth showing that in the exam, even though they haven't asked to prove it's a minimum. But given there's no other solutions, it has to be. Right, find also the value of the surface area in this case. So now I'm going to take this cube root of 120, so I'm going to put the exact number in my calculator again, and I'm going to do 4 answer minus 480 answer to the minus 2. And that way we know we're going to get an exact answer. Oops, and I'm talking rubbish because I've subbed it into the wrong thing. Hopefully you're all screaming into your computers that I shouldn't be subbing it into the first derivative, as I already know that will give 0. I should be subbing it into this here. So I soldier on. So 2 answer squared plus 480 over answer gives me 100, let's say it's 3 significant figures, 146 centimetres squared. Alright, let's double check that. So we got 120 over x squared, blah 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 blah. So our first derivative was correct, so was our second derivative. So you get a mark for setting the first derivative to 0, a mark for getting cube root of 120, and you do get a mark for confirming it's a minimum. So I would, even if they don't ask, I'd do that, subbing in, and then they're allowed anything between 145.9 to 146. Okay, question 11. So the course for a yacht race is a triangle shown in figure 11.1. The yacht starts at A, then travels to B, then to C and back to A. So the first thing I want to do is work out the total length of the course. So we know this length, we know this length, so we're going to have to work out this length here. So let's call it x. Right, so with a non-right angled triangle, we're going to have to use a sine or cos rule. The way I think about which one we pick is, if you know 2 angles, write down the third angle. That's first rule. Second rule, if you know a side and its opposite angle, then use the sine rule. Now in this case, we know 72, we don't know x, and we don't know either of these angles, which means we're going to have to use the cos rule. So we're going to use a squared equals b squared plus c squared minus 2bc cos a, which you should know by heart, but it's in your formula book. So subbing in those values, a squared is going to be x squared, and that's going to be b squared plus c squared minus 2bc cos a, and a in this case is 72. So I'm going to put that on my calculator, so amuse yourselves while I do that. 102 times 348 times cos 72. Make sure I'm in degrees, and that gives me about 147,000. So to get x, I'm going to square root that, and that gives me 383.9 meters to 4 significant figures. But remember, make sure you answer the question. They want the total length of the course. So we've got to add on the 348 and the 302, which in my calculator tells me it's 1,034 metres to 4 significant figures. Okay. Right, so going on to the next bit, I'm going to just write that in there. 383 point, and I'll write 87 just in case I use it in a question I want quite an accurate answer. Right, so given that the bearing of the first stage AB is 175 degrees, so they're saying this angle here is 175 degrees. Calculate the bearing of the second stage BC. So if we draw a north line on BC, we know this whole angle going round to here is the bearing they're looking for. That's the bearing going from B to C. So we need to find this angle here, which is going to be the more difficult one, and also this one here, which is the one a lot of people miss. Now, whenever you see a bearings question, you're almost always going to have to be using angles on parallel lines. So here, we've got these kind of allied angles, or C angles, as some people say. So we know those two angles will add up to 180. So this one must be 5 degrees. So whatever we get for this, we've got to add it to 5 and then take it away from 360 for the bearing. So on this question now, we actually know an angle side pair, so we can use the sine rule. So I know that sine, let's call this angle y, sine y over 302 will equal sine 72 over that 383.87. I've actually got that exact number in my calculator, so I'm going to input it in as answer. So I'm going to do sine 72 divided by answer, and then I'm going to times it by 302, so we get the value of sine y, which is about 0.277 something. And then so if we do the inverse of sine for that, I get 16.13 degrees. Okay, so I'm going to add 5 to that. That gives me this entire angle here. And then for the bearing, I'm going to take it away from 360, which gives me 339 degrees to the nearest degree. Okay. Right, good. Part 2. So this is quite a different question. Figure 11.2 shows the course of another yacht race. The course follows the arc of a circle P to Q, then a straight line back to P. So you can see what's coming here. The circle has radius 120 and centre O, and then we know POQ is 136. Calculate the total length of the course for this race. So again, we're looking at two distances here. First, let's look at this arc. So if we work out this angle, so just 360 minus 136, that gives us 224. Okay, now remember we can't use the nice formula for radians because we're not in radians. You could feel free to convert to it and then do that. But hopefully you remember from GCSE or something that you've got to do theta over 360 times by the circumference, which is 2 pi r. So basically this is the circumference, but we only want 224 360ths of it. So in my calculator, I'm going to do 224 divided by 360 times by 2 pi r. So times by 2 times pi times 120, which is, so my calculator gives me an exact answer, which you could put, in fact, let's keep that exact answer because we're going to have to use it later on. So it's 448 over 3 pi, which in normal numbers is 469 metres to the nearest metre. Right, for this one, we're going to have to work out this distance QP again, and I hope you spotted this is similar to the one before, very similar actually, and we're going to have to use the cosine rule. So we're going to be doing x squared equals, so 120 squared, I'm going to run out of space, plus 120 squared minus 2 times 120 times 120 times cos 136. Okay, so again, amuse yourselves while I enter that into my calculator. 2 times, I've only put 12 there. 120 times 120 times cos 136, and that gives me x squared is about 49,000 or something, so I'm going to square root it, and that gives me 223 metres to the nearest metre. Okay, so that's 3 significant figures. So in total, so I'm going to add on to my exact answer in my calculator, 448 over 3 pi, and that gives me 691.7 metres to the nearest metre. So I've managed to do all of that and never having to round at all. So some of the answers I've written down are rounded, but you should be able to enter that all in your calculator without having to round anything. Okay, so that's the end of 11. 12. So figure 12 shows the part of the curve y equals x to the 4 and the line y equals x, which intersects at the origin and the point P. So first of all, find the coordinates of P. So this is going to be where x to the 4 equals yx, sorry, equals 8x. So this is a polynomial, so we should get it all on one side and then try and factorise it. So we can factorise out an x, and then we've got x cubed minus 8 here. So then we've got two options. Either x can equal 0, which we can see there's another intersection here, so that's what that gives us, or x cubed equals 8, in which case x is the cube root of 8, which is 2. Right, but we've also got to remember we need the y coordinate as well. That's another thing a lot of people forget. So the y coordinate, we can sub it into either equation. So I'll sub it into this one because it's easier. So 8 times 2 is 16. Right, so find the coordinates P, we've done that. Show that the area of angle OPQ is 16 units. Right, so OPQ, handily, is a right angled triangle. So we know the base is 2 and the height is 16. So we can do a half times 2 times 16, which equals 16. So we've shown it. Right, part B, let's keep that there. Find the area of the region bounded by the line and the curve. So there's a couple of ways you can do this. Because we already know this angle OPQ is 16, we can use calculus to find this area. So doing the integral will give us the area under the curve. You can set it up in a different way so we'll get you straight to the answer. But given that we know this whole area, I think it would be easier to find this and then take it away from 16. So to find that, we want the area underneath x to the 4, and we want it between the points 0, where x is 0 and x is 2. So x to the 4 becomes x to the 5 over 5 between 2 and 0. So I've got to sub in 2 to the 5 over 5 minus 0 to the 5 over 5, which is 0. So 2 to the power of 5 is 32, divided by 5 is 6.4. So our area, we're going to have to do 16 minus 6.4, which is 9.6. Okay. So part 2, so we're having to do some calculus from first principles here. We're given that f of x is x to the 4. Complete this identity, so f of x plus h equals x plus h to the 4, which equals, and then is some kind of binomial expansion they've done. So hopefully you remember this is just going to be the coefficients of Pascal's triangle all the way down to 4, so 1, 4, 6, 4, 1. And then your powers of x going down, your powers of h are going up. If you're not sure about that, I'd highly recommend revising binomial expansion. So this would be 4xh cubed plus h to the 4. Right, and then they want us to simplify this. So let's sub in what we've got here and then take away f of x. So the first bit, f of x plus h, we've written up there. It's x to the 4 plus 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the 4 minus f of x, so minus x to the 4, all over h. So can we simplify it? Well, these x to the 4s are going to cancel, and then we can divide each term by h. So it'll be 4x cubed plus 6x squared h plus 4x h squared. Okay, so that's part B. Part C, find the limit as this tends to 0. So as h tends towards 0, what does this become? So obviously if h was 0 here, we can't actually compute it because it would be, you can't have a 0 in the denominator, you'd get an undefined number. But the way we've simplified it, we can see, well, if this is 0, this whole term will be 0. If this is 0, this whole term will be 0. So the answer is simply 4x cubed. And hopefully you recognise that as the gradient of x to the 4. So hopefully when you were learning what differentiation was, your teacher took you through some of these steps. So this is how these are derived. So state what this limit represents. So hopefully you recognise this is the gradient of x to the 4, or the derivative of x to the 4. I think I probably should have put derivative there. So let's look at the mark scheme to check. So just running through these. They seem right. Didn't really check these. I'm very sorry if I made a mistake. So you notice you get a lot of leeway for working out those ones. Question 11. So that looks good. Our 9.6 is there. So there we go. Gradient of the curve, or tangent to the curve. So I actually don't allow you to put derivative. All right. So again, apologies if there's any mistakes. As always, please let me know if you've got any requests, and I'll see if I can get around to them. Thanks a lot.